the calculation of our volumetric analysis, we are going to take the question one by one and then solve them down. Look at the question. It says that B is a solution containing 9.8 grams of iron sulfate in 25 centimeter cube of the solution. A is a solution of potassium tetraoxomanganate 7. It said the question now said A, put A into the burette and titrate against 20 or 25 centimeter cube of B at room temperature. The 25 or 20 centimeter cube is actually the volume of your pipette. Record the volume of your pipette, tabulate your readings, then calculate the average volume of A used. Now in recording the table, tabulating your burette reading, it has to be in this format. The volume of the pipette used has to be here. The burette reading, the first reading, second reading, and third reading. Please, in tabulating your reading, make sure that it is on one decimal place. It must be recorded in one decimal place, one, and then the unit of the volume has to be there, just the way it is here. Then your average volume used is calculated this way. Average volume of A is equals to 18.5 plus 18.7 plus 18.4 divided by 3. So if you divide this by 3, you are going to definitely get 18.37 plus this will give you Q. This is our average titer value, or the average volume of acid used. It said, from your result and the information given above, calculate the concentration of A in mole per dm cube. The concentration of A in mole per dm cube. Don't forget that concentration in mole per dm cube is equals to mass concentration over molar mass. Mass concentration over molar mass. And from here we know that we can calculate the mass concentration. Mass concentration is equals to mass over volume. Mass over volume. The mass given, the mass of A given, the mass of A, concentration of B, conc of B is going to give us concentration of B is going to give us mass of B over volume of B. So mass of B is equals to 9.8 grams over the volume of B, which is 25 centimeter cube. But this 25 centimeter, because there is no information that can help us to calculate the concentration of A now. So we first calculate the concentration of B, since the mass of B was given and the volume of B was given. So we have mass concentration in mole per dm cube of B is equals to mass of B over molar mass of B. Mass in mole per dm cube of B is equals to mass conc of B over molar mass of B. So mass conc is equals to mass of B over volume. The mass of B given is 9.8. The volume of B given is 250 centimeter cube, but you convert to dm cube because we are dealing with dm cube. When you convert to 260 divided by 1000 to convert to dm cube, 250 divided by 1000, 0 will cancel 0.
0.25.
So you have to, so mass conc of B is equals to 9.8 over 0.25. which is equals to, so mass count of B is equals to 39.2. So concentration in mole per dm cube of B is equals to mass count over molar mass 39.2 over the molar mass of B. Molar mass of B is potassium is 32, potassium 32 plus manganese 52 plus oxygen, which is 16, oxygen 16 times 4, 16 times. Molar mass of potassium permanganate is going to be the relative molecular mass of potassium, which is 39, plus that of manganese, which is 55, plus that of oxygen, which is 16 times 4, because there are 4 molecules of oxygen in potassium permanganate. There are 4 molecules of oxygen in potassium permanganate. So it's going to be potassium, manganese, and 4 molecules of oxygen. Then if we add everything here together, we are going to get 39.2 divided by sum of this. 1 0.2
24.810
mole
per dm cube.
mole per
dm cube.
dm cube. That is the answer. B is 0.23 mole per dm cube. So we are going to look at the to get the concentration of A. We are going to use acid base mole relationship. We are going to use acid base mole relationship, which is CV CA over CB VB equals to NA over NB. So in order for us to get NA and NB, we are going to write the equation of reaction of this titration. So the titration is a reaction between iron 2 sulfates plus potassium manganese 4, potassium manganese 4, because it was acidified, then it's going to give us product of iron 3 sulfates plus potassium sulfate plus manganese sulfate plus water. This is a neutralization reaction producing 3 salts and water. In this case, we are going to balance the reaction. For us to balance the equation, we are going to put 2 here. If we put 2 here, then we are going to put 10 here. The iron here is 10, so iron here should be 5. So if we look at 10, this, then the hydrogen here is 2. The hydrogen here is 2. Here. Balance the equation now. 10 mole of this, 2 here, 8 here, 5. Then here, there are 2K. Now the equation is balanced. So the ratio of reaction is actually, the ratio of reaction between the permanganate and iron sulfate is 10:2, which is equals to 5:1. So since we have gotten the equation, we are going to calculate the concentration of A. So using this, we know that our Ca, which is the concentration of A, is unknown. Then Cb, which is the concentration of B, is equal to 0.23 mole per dm cube. Then our volume of A is equal to the average titer value. Is equal to the average titer value, which is 18.6 centimeter cube. 18.6 centimeter cube, and Vb is the volume of pipette, which is 25 centimeter cube. Using the formula, we substitute our values. Okay, we say that N for NA is equals to 5, and NB is equals to 1, ratio of 5. So NA, put A in the burette. So using our equation of reaction, we can say that Cb, making Ca the subject of formula, we can say that Ca is equals to Na times Cb times Vb all over NVVA. So from here we can say that our Ca is equals to Na, which is 5, times Cb, which is 0.23, times Vb, which is 25, divided by Nb, which is 1, times Va, which is 18.6. So calculating this, Ca is equal to 1.5 mole per dm cube. 1.5. The two mole. So calculate the number of mole of ion in the volume of pipette. We know that number of mole N is equals to concentration times the volume. Since number of mole is equals to concentration times volume, concentration of ion is the same thing as the concentration of B. Concentration of ion is the same thing as concentration of B, but the volume is the volume of pipette. So now so this one is going to be 0.23 times the volume of pipette, which is 25 divided by 1000.
0.25.
So equals to 0.23 times 0.0025. 0.0025. So we have 0.25 mole. That is the amount in that. Then the last one said the mass of ion reacted. The mass of ion that reacted. If we have the mass of ion, since we know that number of mole IV, number of mole is equals to reactive mass over molar mass. So we make reactive mass the subject of formula. So therefore reactive mass is equals to
molar mass times
number of moles times molar mass, amount times molar mass times molar mass. Therefore reactive mass is equals to the amount, which is 0.0575 times the molar mass of ion. Molar mass of ion is 56. So 22 gram. 0.322 gram. This is the mass. Write a balanced ionic equation for the titration reaction. This is the equation for the titration reaction. The ionic equation, we are going to pick the ones that are actually going into a redox reaction. Here, the ionic equation is ion 2 here, reacting with manganese 4 oxide manganese 7 oxide, which is minus this, then plus acid, hydrogen is the acid, we have hydrogen, to give us iron 3, then plus potassium and sulfur does not go into redox equation, so we have manganese 2 and then water. These are the ones that go into redox reaction. So we're going to pick the reduction half equation, reduction half equation will give us manganese moved from manganese 7 to manganese 2, which means manganese is being reduced. So have MnO minus 4, then plus hydrogen to give us manganese 2 and water. So we first balance, to balance this half equation, we first of all balance the number of atoms before we balance the number of ions. Manganese here is 1, manganese is 1, hydrogen is 2, and oxygen is 4 here, oxygen is 1. So we can balance the oxygen here by writing 4 oxygen, 4 atoms of oxygen. Then hydrogen has become 8, so here we're going to balance hydrogen by 8. Now to balance the ion here is plus 8 minus 1, which is plus 6, and here is only minus 2. This one, the oxidation number of this is 0. So we are going to balance this, we add electron to here. Because it's reduction, and reduction is actually the addition of electron. Reduction is the addition of electron, so we add electron here. We are going to have NO minus 4 plus 8 hydrogen and plus electron. If you add 5 electrons, it's going to balance it. So we have 5 electrons. Here we have 6 plus 8 minus 1 will give you 7. 7 minus 5 will give you plus 2. So here we have minus 1 plus 8 minus 5 is going to give you equals to plus 2, which is plus 2. So the ion is balanced. Here we have plus 2, here we have plus 2. The ion is balanced. This half equation is balanced. Oxidation half equation will give us the one that is being oxidized is ion, because ion moved from oxidation number of 2 to oxidation number of 3. So ion is being oxidized. So ion is oxidized. So ion from ion 2 to ion 3. So the number of atoms here is balanced, but the number of ion is not balanced. Here the ion is 2, the ion is 3. So to balance the ion, you're supposed to add electron here, but because it's oxidation, which is the removal of electron, you cannot put minus here. So you take it to this side, it becomes plus E minus. So 1E, 1 minus 3 minus 1 will give you 2, which is equals to this. But because the number of electron is not balanced, the number of electron here is 5, the number of electron here is 1. In order to balance the number of electrons, you multiply everything here by 1 and multiply everything here by 5. So we have 5 here, 5 here, 5 here. Then you write the equation together and cancel out the electrons. So you have MnO 4 minus plus 8H plus 5E minus to give us Mn2 plus to give us Mn2 plus 5Fe plus 5Fe2 plus to give us Mn2 plus 5Fe3 plus then plus 5E minus. So E minus will cancel E. So the overall balanced equation is going to be this 8H4 plus 5F2E, then Mn2 plus 5F plus 5F3 plus 2, then plus molecules of water. That's the balance equation.